plus y equal to 3, we know that x plus 2, because that's what y is equal to 3. Well, this is turning into real easy math. X is equal to 1. So system of equations, pretty much, you have some equations, and just so long as you have, well, there's some rules as figuring out whether a system of equations is solvable. The nice thing is, with trusses, it will be, just as long as you follow all the rules, which I'll explain in a little bit. But don't worry, just as long as you're making normal trusses, you'll have a system of equations that can be solved. Okay, so let's go back, we'll label these again. We have A, B, C, D, and E. And we're going to say 1, 2, 3, 4, 5, 6, and 7. Am I getting everything? Yeah, we're good there. Okay, so we can start making equations for this. And this is where, and remember, we're breaking into x and y forces. So A, I'm going to say for A here, what equations can we get? Okay, so we know that we're going to start using a little bit of engineering notation here. The sum of our forces in the y direction are equal to 0, because in static equilibrium, this is not moving. So all the forces in the y direction have to be equal to 0. We know that we have this 250-pound force, plus we have this force here, which is, I didn't do any math here, we'll say this is 60 degrees. We'll just keep everything nice 60 degrees, all these angles. That's easy, that works out nicely. Okay, so now remember from this, we had our, well, we'll just put it here. Okay, so we know that there's a force acting here. So let's say we have, it's our point A. We have 250 acting here, and we have another force acting here, another force acting here. Okay, so we know that we have 250 here, and we're going to break this into our joint 1x and our joint, oh, that's y, sorry, joint 1x and joint 1y. Okay, or our beam, whatever. So we have this, so we'll say this is our y. So we have 250 plus 1 y is equal to 0. Okay. So let's do some forces in the x. We know that that's also equal to 0. And what do we have here? We have 1 x in the x direction, and we have 2 x. This is going to get confusing. I should do this different. Sorry. We're going to do our joints numbered, otherwise that's going to start confusing algebra. Whatever. Oh, here we go. Let's try this again. Joint 1. Okay, and then we'll say A, B, C, D, E, F, G. Okay, we got 1, 2, 3, 4, 5 joints. Okay. So, sum of the y's is A in the x direction. This is going to be A, in the y direction. A in the x direction plus B in the x direction. Okay, So that's for joint 1. So there's 2 equations. This up here is joint 2. Who wants to do joint 2?
Come on, big man.
I'm here,
You got
I'm
it.
here.
You got it. No,
Okay.
Ethan's gonna do it. He's good.
I'll write out your basics here. Fy is equal to 0. And we might need a little more space. That's fine. And sum of the forces in the x direction are equal to 0. Okay, so now you do a free body diagram of joint 2 here. So show me all the forces that can be acting on joint 2. Okay, what can act on joint 2? Yep, that's going to be what? And how would you label it?
What's it labeled up here?
Oh,
You're right. Perfect.
Yep. So
There.
you got your A. Okay, so we got A. Perfect. What else?
Come over here so you can see.
Yep. And what's that? C. And what else?
Nailed it.
Yep. That's D. Perfect. Okay, so now we got to get those into X and Y components. We don't have to solve for them. We'll figure that out later. So what are all the ones that can be acting in the Y direction?
A and C.
Yep. Okay, so go ahead and write that out. 0 is equal to A and Y. So we know it's the Y component of that. Plus C1. Okay. Now what about the X?
D
Mm-hmm.
A
Yep.
and C.
Yep.
Boom.
There we go. Okay. Now we got more variables here, right? And we've got some variables up here. So let's try to solve for our joint 2 here.
Okay.
So are we going to need to solve anything else first? Can we solve these? Do we know any of these variables?
No. Wait.
We don't right off the top of your head. You know, we don't have like, oh, AY is equal to or AX. Okay. But we have these equations up here to work with. Can we solve anything from that?
The top one?
Okay, yeah, so go ahead and solve that. We'll help you along the way. Well, here, we'll clear up some more whiteboard space, actually. Okay.
I was gonna say they're gonna like that. Brad was just being mean. By the end of it, you'll have that memorized. It's been a long time since I had it memorized. When Brad erased it, I was like, man, if he looks at me and makes me...
You guys don't remember SOHCAHTOA?
Yeah.
Yeah. You gotta like think, I'll send over Jason.
Okay.
Yeah.
I program. I got to sign instruction.
Okay, so go ahead and, so we need to solve for AY. So go back to joint 1.
Okay.
I need to draw a free body diagram of that. Yep. So now we don't want to solve A and, okay, I guess you got one more. So go ahead and put that in. That's your B. Okay. Now, B is nice because it's already in the X direction. So we're good there. I don't like that A though because it's not in the X or Y direction. So what can we do about that? There we go. Break it into our X and Y components. Perfect. Okay. So let's go ahead and draw a triangle there. And we know, what do we know about it? From this equation right here, what do we know? This is our A overall. What's this?
Oh, 250.
Yep, because we know that there's 250 acting up, so we know that A has to have 250 acting down. Okay? And do we know any angles on that triangle? Yeah, I'm like
60.
Yep, so we got 60 degrees here. Okay. So you said we know that AY is 500. Or 250, sorry. Okay, that's a good one. Perfect. And do you want to go ahead and solve for AX? So we have our adjacent, and we have an angle, and we're looking for the opposite. You wrote it before, and I just erased it. Wait, is that right? Tangent of theta, and what's theta? Is that the adjacent side or the opposite side? Theta should be our angle.
Oh,
There. Yep.
there.
Okay. Okay, perfect. So we can go ahead and solve that. And do that real quick. We'll just write it
What are
out.
we going to do to both sides to get down to just the opposite? First, they divided by it, so we want to make that disappear, right? So what do we do with it?
Multiply it.
Boom. So now you multiply both sides by 250. So your answer is 250 times the tangent of 60.
Mark that down. AX is equal to 433. Okay. Now, we know AX. Can we solve for anything else with these equations?
BX.
Yeah. What's BX going to be?
Nope,
Okay,
you're
so
right.
0 is equal to AX plus BX.
So we want to
AX
get
is
down to
433.
just BX. How do we make the AX disappear?
We
Over here you were dividing, so what'd you have to do to get rid of it?
multiply.
So over here you're adding, what do you have to do
Oh,
to get rid of it?
To 433.
Yep. So we know that that's 433. I haven't really been doing your positives and negatives, which you should be doing. If you think about your X being up and your Y being over, you'll know if this one's pushing down, so your AY, how much is it pushing up? It's pushing up by negative 250. And same thing for your AX. If it's pushing left, how much is it pushing right? Negative 433. So then all our math starts working out
Yep.
because A is negative, B must be positive. Okay, so we're good there. Kira, why don't we swap out?
Oh, good job.
What can we do about these equations here?
Could we just plug in AY for
Oh, there.
negative two?
That seems easy.
Yeah. So CY would be 250.
Okay. Okay.
We can only plug in negative 433 for AX, so we need to solve for CX and EX, or just one of them.
Okay. So, can we solve? How else could we get to CX?
We can draw the body diagram and solve it with that.
Yeah, because we know
That make you uncomfortable?
one of them, right? We know CY. So we can figure out what C is total, and from there we can figure out what CX is.
Okay.
So you want to do that?
I'm trying to find C.
It's
No, you're right.
here.
Find C. Yep. Sorry.
So I don't know how to.
Yeah, you're good.
And then it's
So you want to break that into X and Y components, right?
so that would be
Yep. Here, CY. Yep. It's 250.
and then this is 60.
Yep. There's your 93.
And then this lead time C.
Yep.
Okay.
That would be 144. Okay. Go ahead and write it down. Now, can we solve anything else there?
You just add AX negative 433 plus 144.
Yep.
Could you go get
Yep. Oh yeah. Yep. Yeah, that. 144 minus. Okay. Negative 289. Okay.
so then dx is going to equal 289.
Yep. Now it would be negative, so go ahead and throw that on there. And that just means the only thing the negative means is that is it pushing that way or it's going that way, and it's going this way, pushing out. Because remember we said this was a compression number, so you have these two sides kind of pushing in, and D has to push out to keep those two pieces from going in.
Okay.
Okay. We're gonna start erasing a little bit more. Oh, D was negative 289. D in the X equal to negative 289. Okay, and what's dy? It's this one right here.
It's not.
Yeah. It doesn't do anything. It can't push up and down. It's just running vertical, so it's 0.
Okay.
So, and I think like for B, same thing. So BX and BY will both, BX is equal to 0, Y, sorry, Y equals 0 and dy is equal to 0. Now, we got one left to do. This one right here. So, actually, wait. We've solved for A, we've solved for B, we've solved for C, we've solved for D. Now, this is where we can do a little bit of math to check and see if this all makes sense. Okay, so we know that this one, this A here, is, let's do a y is 250, and we'll ignore the negatives for right now, we're just doing scalar, just check our math here. And ax is 433, and then c is 250 and 433, or no, 250 and, did I erase our c? Oh yeah, cx, x, 144. And E is 144 and 250. Now, why can I say that?
Because it's the same.
Yep, it's
Symmetric.
mirrored. Yep.
Because what?
Symmetric.
Boom.
Yeah. B here we said was
Bushel of corn equals a
433
bushel of beans, right?
and 433. Okay. So now let's draw our free body diagram for point 3. We have 500 pounds pulling down. We have C pulling up and E pulling up. And we have B pulling over and F pulling over. Okay. We know what F is, we know what B is, we know what these are. Okay, so these are the only two. C and E are the only two that we need to break down into their components. We already have those broken down. We know that C, I'll do it over here. C is 250 in the Y and is 144. And we know the same thing for E, right? So, do our numbers seem to work out? Let's balance our X's, or balance our Y's. So we've got sum of forces, I'll go over here. I hate being left-handed and doing whiteboards. Okay, is equal to, so we got negative 500 for our load, plus CY plus EY, which is equal to negative 500 plus 250 plus 250. Seem to check out?
Now, when he first wrote this down and you guys were kind of scratching your heads a little bit, right? You can admit it. Now you understand why, right? That's what he meant by when he said all forces have to equal zero.
Do you know what this
Yeah.
symbol means? The sum, it's pretty much just take all of those things and add them together. Okay, so sum of the forces in the y direction check out. Let's do the same thing for the x. So we know sum of forces in the x is equal to 0 is equal to, we've got nothing here. We have bx plus fx plus cx plus ex. And this is where your positives and negatives do play in a little bit. Which direction is this going? Is it going that way or that way, this E? Is it going right or left? It'd be going right?
So see, this is to the right, and this is to the left. So is that positive or negative?
Positive.
Yep, so this one is positive, and we know that. So for E, we had said that's the same as 144. So we'll say this is equal to Okay, so we'll go B first. B, pulling in, so it's going this way. So we have B is negative 433. Wait, no, that should be positive, sorry. Plus F, which is our negative 433.
Now, just real quick before he moves on. Now, if we just imagine that we pulled this down, right? That would pull this away, which would move this one to the right and this one to the left. That's how he came up with his positive and negatives. Sorry.
You're good. Yeah, that's like for this double check, don't worry about your negatives and positives. Just kind of figure them out as you need to, and it's fine. Like, it's good to keep track of it, but don't get caught up on it. It's pretty easy to change at the end if you're like, oh, I had that reversed. And then your CX is 144. Nope. Four. Now it's getting pulled down, so it's going to be going this way, so that's positive. Plus your EX, which is negative 144. Okay, so that all checks out, right? Yeah, these two cancel each other out. Those two cancel each other out. We're left. Solves, it's 0. We're good. So now we've figured out all of our forces. Seem like a good spot?
Yes.
Okay.